8.7 Radical functions and inequalities. Some problems to practice on. Okay, so in this section we will be graphing radical functions that can be transformed by using methods similar to those that you guys use when transforming linear equations or quadratic functions. So let's start with the different transformations that can be done to the square root function. So we have f of x equals a times the square root 1 over b times x minus h plus k. Your a and your k, those are your vertical transformation. And your b and your h, those are your horizontal. Okay, so let's start with vertical movement. Okay, so let's start with our parent function, f of x equals the square root of x. It looks something like this. So if we have g of x equals the square root of x plus 2, that means we're moving f of x 2 units up. So it will look something like this. G of x. Okay. Now let's talk about vertical stretch or compression. So we have f of x equals a times the square root of x. If a is greater than 1, then it's a stretch. If a is less than 1, it's a compression. And if a is less than 0, it's a reflection across the x-axis. Okay. So once again, we have f of x. Okay, what if we want to graph g of x equals to 3 times the square root of x? Since 3 is greater than 1, then the function f of x is stretched. So it's going to look something like this. G of x. What do we have? H of x. 1/3 square root of x. Since 1/3 is less than 1, then it's a compression. So it's going to look something like this. And what if we have j of x, which equals negative square root of x? That's going to be a reflection on the x-axis. So it's going to look something like this. Okay, now let's talk about horizontal movement. So we have f of x equals the square root of x minus h. H is the movement either to the right or to the left. So once again, let's start by graphing f of x, our parent function. So what if we have g of x equals the square root of x minus 3? Then we're moving 3 to the right. That would be g of x. Now let's go over horizontal stretch or compression. So we have f of x equals the square root of 1 over b times x minus h. If b is greater than 1, it's a compression. If b is less than 1, it's a stretch. And if b is less than 0, it's a reflection across your y-axis. Okay, so let's do an example. Here we have g of x equals the square root of 1/2 x. It's going to be a horizontal compression by 2. So then it's going to look something like this. G of x. If we have h of x equals the square root of 2x, then that's going to be a horizontal stretch. So what do we have? G of x, the square root of negative x. Then it's going to be a reflection across the y-axis. So then it's going to look something like this. So now let's do another example. What do we have? G of x equals the square root of 2x minus 4. We can rewrite it as the square root of 2 times x minus 2. Therefore, we're going to have a horizontal stretch and we're going to be moving our graph 2 units to the right. So if we graph our parent function, it will look like this, f of x. And if we graph g of x, then we're moving 2 to the right, and it's going to be a stretch. So that would be g of x. Okay, what do we have? G of x equals the square root of x minus 3 plus 2. So we know we're moving 3 to the right and 2 up. Okay. So this is f of x. So we're moving 3, 1, 2, 3, and 2 up. 1, 2. That's going to look something like this. This is g of x. Okay. So what do we have? H of x equals negative square root of x minus 3 plus 2. This is going to be a reflection on the x-axis. And this is going to be a movement of 2 up. And this one is going to be a movement of 3 to the right. So first we want to move our graph 3 to the right. Then we're going to reflect it. And then we're going to move it up to 1, 2. So that would be your graph. Okay, so now let's do transformation on the cube root. So let's start by graphing f of x equals the cube root of x. It looks something like this. That's f of x. So what do we have? G of x equals negative cube root of x. So that's going to be a reflection across the x-axis. So it's going to look something like this. G of x. What do we have? H of x equals the cube root of x plus 3. Then we're moving our graph up 3. So then it's going to look something like this. So now what do we have? J of x equals the cube root of x minus 3. So then we're moving 3 to the right. So then it's going to look something like this. And that would be your J of x. And those are transformations on the cube root. So now we're going to be graphing radical inequalities. And so what do we have? Y is less than the square root of x plus 2. Well, you guys already know how to graph the equation y equals the square root of x plus 2. It would be the graph of f of x, and you're moving it up 2, the prime function. F of x equals the square root of 2 of x. I'll do this on another video.
Okay.
Stop it.